Okay, good afternoon to all the participants. My name is Ernst Wassenaar. I'm the regional manager for geomill equipment in Asia Pacific, and I will talk a little bit about how the CPT is used in a marine environment. As the time is limited, I will go through rather quickly. If there are any questions, please feel free to raise them. Either directly after this session, or later on you can always drop me an email or contact me otherwise, and we'd be happy to answer any questions you may have. So, okay, to start off with, why is the CPT important? Why is the cone penetration test important? Well, very generally speaking, you can say that a good understanding of the subsoil is necessary for the design of anything that relies on a proper foundation. Whether that is onshore or offshore, that doesn't really make a difference, but of course this conference focuses on offshore, so we will also focus on that. In short, you can say that ground investigation is a must for any construction project. If we want to understand the importance of the CPT, we have to look at the ground investigation. We have to look at the bigger picture of ground investigation. So if you look at the definition of ground investigation, then you can say that it is sampling, testing, logging, and modeling of the physical and chemical properties of the ground. And there are many methods, many different methods to do that. And the cone penetration test is only one of them. It is one of the very fast developing and also one of the most efficient methods. You always have to keep in mind that the best ground models are created by using a combination of methods. So even though we as a CPT manufacturer will obviously advocate for the CPT, it is only one of the methods. And I always say you should never rely on just one method. You should always use a combination. It's important to keep in mind that ground investigation as such typically only accounts for a very small percentage of the total construction cost. And more importantly, that it is wise to spend on investigation, to invest in an investigation upfront, as it will lead to lower construction risk. And therefore, at the end of the line, it will also lead to less cost escalation. So don't be penny wise, pound foolish, but do spend or budget for a proper ground investigation. Now, once again, there are very many methods for ground investigation. There's a huge variety to choose from, but typically for a marine environment are the CPT, the SCPT, the seismic CPT. Another combination with CPT are the full flow penetrometers, such as the T-bar and the ball, shear vein testing, drilling with coring or sampling, pressure meter testing, packer testing, and obviously also geophysical testing. There are probably quite a few more, but this is, you could say, a summary of the most common methods. Now, for those who don't really know what CPT is, a very brief introduction. The CPT is a ground investigation technique used in soils. It's not suitable for rock, but in soils it can be used. It constitutes advancing a conically shaped tip into the soil at a constant speed, and you measure the parameters while you do so. It provides soil strength and behavior characteristics. It uses a standardized speed, as I already mentioned, 20 millimeters per second. You use reaction force in order to be able to push the cone into the ground. And typically you use hydraulic rams, although for some offshore application we use different technology. But the vast majority of systems uses hydraulic rams. We use electrical cones nowadays. Mechanical cones are something of the past. Those electrical cones allow for a downhole measurement, and that provides real-time data. Unless it's used in memo mode, but that's a very special application. It measures three basic parameters, which are cone resistance, QC, the sleeve friction Fs, and the pore pressure, and that's typically U2, where the U2 stands for the filter location. I won't go into too much detail here, but the U2 position is typically the default position of the filter. Schematic drawing of an electrical cone. You have the cone tip measuring the QC cone resistance. You have the friction sleeve behind the cone tip that measures the sleeve friction or skin friction. The pore pressure filter, as I already mentioned, this position is known as U2. And then we have dirt seals between the tip and the sleeve, and between the sleeve and the rest of the cone. They are a flexible barrier, you could say, that allow the parts of the cone to move. So that allows the cone tip to move and allows the friction sleeve to move. They have to do so in order to get your measurements. And then finally at the back there's a connector where you typically connect your data acquisition system or your battery pack or things like that. The advantages of CPT compared to other more conventional ground investigation methods. It's a very effective and efficient alternative, or maybe the better word is to use is it's a complementary method for conventional site investigations such as drilling or SPT. It's an in situ test, meaning we measure there in the ground where the soil is in its natural condition, without the risk that it is affected by any type of external influence. It provides normally real-time data, so it means the moment we do the test, we have the data. It is a big advantage. It's an established, very well established and recognized method. It is repeatable, accurate, and reliable, with a big if, and the if is if you do it properly and use the right equipment. But that's sort of that statement is sort of valid for any test method. Now you have to do it properly, and you have to have the equipment that is fit for the job. It is very fast. There's a standardized speed, as I already mentioned before, 20 millimeters per second, and this high speed is probably the most significant and advantage of the CPT. We can gather an awful lot of data in a relatively small time. It provides very high resolution, very high sensitivity data at a very, very high level. And another advantage is that there's a variety of specialist sensors and add-ons available, such as we already mentioned earlier, the T-bar and the ball, seismic measurements, magnetometer, and there are quite a few more than just these. But again, it's an advantage that you can add that to the normal CPT. Unfortunately, there are also a few limitations. Soil conditions may limit the use of CPT, for example, due to gravel, boulders, or rock. And the depth might be limited due to reaching maximum thrust. You can only push with so much force, and there's a limit to that. Now, these limitations can be overcome with certain other CPT methods, but a little bit more about that later. It might be impossible to obtain sufficient reaction force. As I mentioned earlier, you need a reaction force you need a thrust force, but therefore also reaction force to penetrate the cone into the soil, and it might be impossible to have sufficient reaction force. Usually this reaction force is generated by dead weight, but sometimes it's more complicated than that. CPT requires trained operators and good understanding, not only among the contractors themselves, but also among consultants and clients. And we see, unfortunately, this is not always the case. So that is a point of attention. Now, if we look at the typical marine environment, then what are the projects and applications where we see the CPT? Very crude, very broad, you could say that the CPT is suitable for any geotechnical problem as long as the soils that you are testing are suitable for CPT. But more specifically, you can say that the CPT is very common for pile foundation design. The CPT in itself is a miniature pile test, you could say. Same goes for lag penetration studies. Remember the picture I showed on one of the first slides where you could see a punch through. That's obviously something we would like to avoid, and the CPT is an excellent tool to get this information. Soil improvement, so any location where soil is either compacted or mixed or well, reinforced, you could say, that's where the CPT excels, especially when you need a lot of data in a short time. Think, in this particular case, think of like big reclamation projects, such as the Hong Kong airport as a prime example. Settlement prediction, again, very, I should say, significant use of the CPT for settlement prediction, especially in reclamation projects where a sand fill is placed on often very soft subsoils, and then settlement will take place, and it is very important to understand how much settlement is to be expected. A very I should say a very, very popular use at the moment, wind turbine foundations. All over the world we see more renewable energy coming up, and wind turbine foundations, again, a very typical application for the CPT. Well, any offshore construction, think of oil and gas structures, platforms, anything you can think of. And of course, pipeline and cable routings and landings, where this sort of infrastructure comes on land. It's a very challenging environment to do testing, but the CPT, as it is a very fast method, is ideal for this sort of projects. So how does the equipment look like? If you look at nearshore, we can say there are, or you can sort of subdivide it in two different categories. You can say that there's the very conventional setup where you use a floating barge. The problem, however, with a floating barge is that there's always heave, and this will affect your cone readings. It will affect your pore pressure readings. It will affect your cone resistance readings in particular. Therefore, a floating barge is not really recommended for a standard CPT operation. So you cannot use a onshore CPT rig, put it on a floating barge, and expect high quality data. In order to overcome this, but still a conventional method, is to use a jack-up barge, where, of course, the effect of the sea is diminished in the sense that heave, tide, etc. do not play any role. There you can use a conventional CPT setup, put it on the jack-up and do your test. This is also known as top push, as it is pushed from the top of the system. Now, there are also dedicated solutions using a riser system. The geomill shark system is a typical example, but there are more systems on the market that use this sort of technology, where you can use a floating barge, but the CPT system itself is independent from that barge. So there's a foot on the seafloor, and then a riser construction going to the surface, where you actually conduct your CPT. I have a little video that shows you how this works. You can see the movement of the platform relative to the riser construction. So as if it looks as if the CPT rig is moving, but in fact, barge stand still. Object, and even those sheltered, relatively shallow waters, quite substantial. Yeah, now, next to these, you could say, dedicated nearshore systems, there is also an increased use of seabed systems for civil works and wind farms, specifically in areas where there's an awful lot of CPTs to be carried out. And this is an example where you see a seabed unit used for civil engineering work in Singapore. If we make the jump to offshore, there are two basic methods. One is the seabed operated system. There are a few systems on the market. We as Geomill, we produce the Menta system. Our colleagues, AP Vandenberg, they make a system known as Rosan. It's also a seabed operated rig. Then Datum from the UK, they operate, or they supply a rig called the Neptune, but it's more suited towards miniature cones with coil-up rods. And then Fugro have their range of seabed operated systems, but they are only there for self-use. They don't supply these rigs to the market. The alternative method is a downhole method where you push the cone from the bottom of a drill string. And this is a system, if you look back a few slides ago, I was talking about overcoming difficulties or overcoming limitations. And this is a method that you can use to overcome these harder layers or rock or gravels, or whatever you think of. Two systems again on the market, the Orca from ourselves, GeoMill, and then our colleagues from AP Vandenberg, they make the Wison system. And again, Fugro, they have their own system, but it's not up for sale. There's no commercial use for it. These downhole systems, they are used in combination typically with sampling or other GI methods. Think of a vein shear, for example. And then finally, there's a hybrid system which is available, which is the Bentic Prod. It's a seabed drill used for seabed deployed drill and CPT. It's very specific, and it's again not available for sale, it's only for self-use by Bentic. Okay. Picking the right equipment and deployment method is very important. Keep in mind, look at the objective of the testing program. What is the purpose of the investigation? What kind of soils are we testing in? What is the quantity of work in hand? Are we only doing a few tests, or is it thousands or hundreds of tests that we need to do? Then, of course, you need to look at a different set of equipment. What are the conditions? Think of water depth, tide, current. They will determine what sort of equipment you need to use. And not unimportant, also what is the marine plan that is available. Finally, experience and quality of operators is also important. Keep in mind, and this is sort of a summary, you don't need an overkill in terms of equipment, but it's definitely important to have redundancy in this. Okay, very short, few last slides, challenges, operational issues and errors. Look at this, for example. This is a downhole system where you can see short strokes, but what you can see if you zoom in is that this borehole was probably overwashed, meaning that the consecutive CPTs are affected by the borehole, and the first few data samples of these tests are unreliable. Cone condition is important, zero readings and the zeroing location. This is another example. On the left-hand side, the readings as reported. The consultants thought this could not be correct, so they looked at the zero readings and what they were in reality and what they should have been theoretically. And then on the right-hand side, you see the corrected CPT data. But it's obviously best to try to prevent this sort of things happening. Cleanliness is very important. So you can see the dirt seals on the cones are important. Water seals, the wear and tear. Piezo cone saturation, very important to prevent sluggish pore pressure readings. And the penetration speed is important to keep in mind as well. Same as malfunctioning depth measurement, something that is very often overlooked. What are the challenges we have to deal with? The poor understanding of the standards. Unfortunately, among clients, there's a market-wide lack of understanding of the objective of the application classes in the current ISO standard. People very often say, I want the best, so I need class 1. That's not what the application class is meant for to be. It's extremely difficult to accurately assess the application class achieved for a CPT, and there's not yet a clear understanding how manufacturers as ourselves can assess or measure the application class for a particular cone. Unfortunately, there's too much reliance on experienced drillers or untrained workers all over the world. CPT operating companies are cutting corners, unfortunately, and therefore not adhering to quality standards. And sometimes also these same companies choose for cheap, low-quality equipment. And that obviously, results also in lower quality data. And then finally, what we see on a daily basis is that consultants and clients are too focused on the data, so they are too focused on a friction ratio, three positions behind the decimal pointer, but they fail to understand the bigger picture of ground investigation. Something else we see is that contract specifications are largely copied from project to project. This was a very brief overview